Today's section 4.6 is talking about inequalities for one triangle. So our first theorem says that if two sides of a triangle are unequal, then the measures of the angles opposite those sides are unequal, and the larger angle is opposite the longer side. So it seems like a lot, but we'll break it down on this one. So our first piece, if two sides of a triangle are unequal, so if we looked at angle or side 10 and 13. Two sides of those triangles are unequal. The larger angle is going to be opposite the longer side. So if I look at the opposite angles to those sides, I have this angle A right here and this angle C right here. Just looking at those sides, I know that angle A is going to be bigger than angle C, because this angle A has a larger side opposite it. So that's going to be the same for this side 16 too. Side 16 to angle B, that's going to be my largest angle because it's my largest side. So then the same goes for my other angles. My smallest side is 10, so that's going to make C my smallest angle. So we could put our angles in order from smallest to largest by writing the measure of angle C is going to be less than the measure of angle A, which is going to be less than the measure of angle B. B is our largest, and C is our smallest. Okay, and I know it gets confusing here with these angle signs and the less than or greater than signs. So for our angle symbol, I'm going to write this little symbol in the corner. This means angle, and this means less than. So I'm going to fix that in our statements. We have this is the measure of angle C is less than the measure of angle A, which is less than the measure of angle B. Okay? So then theorem 5.14 says that if the measures of two angles of our triangle are unequal, then the sides opposite those angles are unequal, with the longer side opposite the larger. So that is saying basically the same thing in reverse. It's the converse. It's saying that if we have 90 degrees here, 60 degrees here, 30 degrees here, we would know that if this is 90, our largest side is going to be across from the largest angle. So this would be largest side. And our smallest side would be across from the smallest angle. So if we were to put our sides in order, from smallest to largest, our smallest would be BC. And then our second smallest would be AB. And then our largest would be AC. Okay, this example says to list the sides in order from smallest to largest. If these are our angle measures, we're trying to list the sides from smallest to largest. I find the smallest angle, just 20 degrees here, and the side across from that is side EF. So that's going to be my smallest. Then my next largest is 50, so that side would be DF. And then my last side, my angle 110 is the largest, so that leaves DE. My sides from smallest to largest. This next example asks us to list our angles from smallest to largest. So to do the same thing, we are going to look for the smallest first. So we find the smallest side. That makes our angle B our smallest angle. Then our next largest is 7, so the angle across from that is angle A. And then our next angle across from our largest side is angle C. The last theorem is the triangle inequality theorem, and this one says that the sum of the lengths of any two sides of a triangle is greater than the length of the third side. So if we look at some of these examples, it's asking, can the lengths given below be the lengths of the sides of a triangle? So if we look at the first one, it has side lengths 3, 5, and 7. So the way we're going to check that those can be a triangle is to add up our smallest two, which in this case are 3 and 5. So if we add up those two sides of our triangle, 3 plus 5 gives me 8, and 8 is larger than the third side of my triangle. So since 8 is greater than 7, I know that these sides could be a triangle. Our next one, we've got 8, 3, and 4. So if I take the two smallest sides of my triangle and add them up this time, I get 3 plus 4, which is 7. In this case, 8 is bigger than those two sides added up together, so this triangle, or these sides, cannot make a triangle.